Hello everybody. As I promised, I decided to share a very brief video telling you more about a new algorithm that I implemented into the Exo-Striker toolbox, with which you can detrend transit light curves very easily, very quickly, and very efficiently. Um, and I hope you find it useful. I mean, I just played these days with it, and I really find it really nice. Of course, this is not supposed to replace some more complicated analysis, but just as a quick analysis, quick look, I think it might be quite useful. So for the purpose of this video, I choose um, to work on data from WASP 6. So I will just include the light curve, the original light curve from test sector 1. As you can see here, this is the non-normalized photometric light curve. And this is exactly what you're gonna get from the lc.fits files. So basically this is really raw over here. So the way to go is once you include the data into the tool, you go to data options and then you click the trend and you will see a second window. So on the second window there are two plots. On the top panel we see the original data. This is on the y-axis the flux. The black curve over here, the black data, sorry, the black flat line over here, it's simply the mean by default of the data, and on the bottom panel we see the normalized flux by the mean. Now, of course, this is not optimal. You see there are some systematics, and we cannot work with that. But the tool offers many different algorithms that you can actually tackle these systematics over here. For example, we can use splines, polynomials, regressions, or even Gaussian processes. Now, I'm not an expert, and I don't know which method is the best and which method it's more appropriate for the test light curves. Maybe the Gaussian process is the winning model here, but we can of course apply some less expensive models that can do very decent job. So you have to really try it yourself. I mean, I just know how to code it, and I did that. So you can interactively play with the data. Meanwhile, all these plots are fully interactive. You can actually, after you're done, you can export the plots, or you just have to play a little bit and see how that works. So for example, I play a little bit with splines and I find them very useful. They're very quick. And okay, you see, now we apply the spline and the light curve looks pretty flat now. And here we see the transits. You can apply some other splines like H-spline, for example. That will give you a little different output, or maybe some regressions, let's say. I'm not really familiar with all the methods over here, but for example, we can try here. Okay, that gives you not so good output, but I'm pretty sure if you play a little bit with the window light, for example, you might get something more smoother like this. This is a little more acceptable. Okay, so basically this is what I wanted to show you, that you can include any TESS data and you can do a quick and dirty analysis, and you can basically flatten the data. Now, once you're done, once you're happy with your normalization, what you can do is just close. It's already saved in the memory, and if you want to apply that, you can just click over here and do apply, and then in the tool you have the normalized data. And now we can do a lot of more complicated analysis. We can also look for the transits with the TLS. Just to speed up a little bit, I think we can go here and just do some lower oversampling factor, and we can just calculate the TLS. So it takes some time. Of course, more CPUs you have, the faster the calculation is done. But it's working pretty fine. TLS is pretty good algorithm, and I really like them for transit search. So okay, so just in a second we'll get the transit, the TLS spectra. Okay, so the 3.36 days is the planet, and then the other peaks are the harmonics of this period. So we can just adopt the period, and we can look over here, and we have already a good model to start more complex analysis of the transit light curve. Of course, I mean, maybe we can see it here a bit easier if you just do a phase folded plot, and I think the 2-minute cadence data looks pretty good, and the model looks sufficient. But of course, we might want to optimize some of these parameters. I don't know, like the time of time of transit, the period, eccentricity, or maybe even some limb darkening coefficients. I mean, you can do that with optimizing the fit, or MCMC fit, or even nested sampling. But this is a subject of another video. I do plan to have this kind of videos explaining a little more how to work with the Exo-Striker. But the bottom line is that you can use the Striker as a quick and dirty check of your data. Yeah, basically that's it. If you have any questions regarding the tool or the algorithms, maybe you can contact me, and I'll try to answer some of the questions. But basically, it's I guess it's trial and error. So you just have to try it yourself and see which of these algorithms might flatten your light curves best. Okay, so thank you very much for the attention, and let me know if you have any questions.